This is Rick from MathX, and before we go into solving this problem, I'd like to take a moment to thank all my viewers. As you guys are probably aware, we recently hit 500 subscribers. That's crazy. We've only been making math videos for a year. But for us to get 500 subscribers in only a year, me and my partner, we didn't even imagine this happening. So I would just like to thank all of you viewers out there for supporting us. And it's because of your support that we're able to make these videos. Because of us hitting this threshold, we'd like to just expand our horizons. So far on this channel, we've only been covering math competitions. However, seeing as we just hit 500 subscribers, I think this is a good time to start creating video solutions for other types of competitions. We're going to still create math videos so you guys can get better and learn how to solve new math problems from math competitions. But I think it would be interesting if we start making physics videos as well. Now, for most people, physics is a really scary and hard to approach topic. And when I say most people, I mean myself included. I remember when I started physics, the concepts themselves seemed quite hard to grasp, and the problems were unapproachable. However, just like math, a lot of the concepts aren't too hard to grasp, and it really just comes down to practicing and developing your problem solving abilities. Which is why I think physics would be a good topic to cover on this channel. Because on this channel, we like to develop our problem solving abilities. So here, I've taken a problem from the 2019 F is equal to MA exam. For those of you who are unaware, the F is equal to MA exam is a 25 question multiple choice physics exam that is the first test in a series of tests administered by the American Institute of Physics to select the team to represent the United States at the IPHO. People who get above the certain cutoff on the F is equal to MA exam qualify for USA PHO. And from there, the top 20 finalists are invited to go to a study camp, kind of like the MOP of physics, and later prepare for the IPHO. So pretty much, the F is equal to MA exam is kind of just like the AIME of physics. So it's a quite difficult test, but the problems on it are quite interesting as well. So without further ado, let's get into this problem. The number 14 from the 2019 F is equal to MAB. A ball is launched at a speed v at an angle theta above the horizontal towards a vertical wall at distance L away. It bounces elastically off the wall and falls back to its launch point. What was its initial speed? So this problem is quite simple. We have a ball, it's launched at an angle theta towards a vertical wall, and it bounces elastically back to where it originally came. So for all physics problems, it's really useful to draw a diagram. And since in this problem, it describes a ball's motion, we should try to draw several diagrams to understand what's really going on here. So here, I'm just going to draw a couple of diagrams for us to look over. So here, I've drawn the ball in two states. The first state is when it's initially launched towards the wall. And the second state is when it bounces off the wall back to the ground. Now, since the problem says that the ball bounces elastically, we know that energy and momentum is conserved in this collision, which means that the ball's motion before and after the collision are exactly the same. So, since nothing really happens to the ball, in fact, it literally lands back in the same position, it makes it very clear that the wall really just redirected its movement. If the wall wasn't in the way, the diagram of the ball's motion would have looked something like this. So it pretty much is the same as the distance the ball travels from here to the wall and the wall back. And in the problem, it says that this distance is L. So then the problem pretty much comes down to at what speed must the ball be launched with in order to have a maximum range of 2L. So if you just recall your basic projectile motion formulas, you will realize that the formula to obtain the maximum range of a projectile at angle theta and initial velocity v is simply v squared sine 2 theta by g. And since we need this horizontal range to be equal to 2L, we'll set them equal to each other and then simply just solve for v. So just multiplying by g, dividing by sine 2 theta, and taking the square root, we get that v is equal to the square root of 2 LG by sine 2 theta. Or answer choice E. So to solve this problem, we really didn't need too much knowledge or information. All we used was a couple of diagrams of the ball's motion, an understanding of what the elastic collision would do to the ball's motion, and then the simple kinematics formula to solve for V. So even though this is a F is equal to MA number 14, so it should be decently hard, using simple problem solving abilities and physics concepts, we were able to solve it. So once again, thank you guys for all the support you've shown this channel and helping us get to 500 subscribers. And in the future, remember to not only look out for any upcoming math videos, but now any new physics videos as well. And be sure to put in your recommendations for problems that I should solve. Even though I might not be able to get around to all of them, I'll try to use your feedback and do all the ones I can possibly do.